Here's a half-life application problem. The population of a bacteria culture is cut in half by an antibiotic every 30 minutes. If entire bacteria culture is present at 5 am, what fraction of the bacteria culture will be left at 9:30 am? Part B is, at what time will the bacteria culture contain 1 over 128 of its original population? Okay, now here the half-life is 30 minutes, so we can say half-life is half an hour, right? 30 minutes is half an hour. Okay, now the half-life formula is that, let's say n is the number of bacteria at any instance of time t, then n0 is the starting bacteria culture, and half-life formula is half, and we have t over half-life. Okay. Now in this case, since we are interested in the ratio, so we are not really interested in any particular numbers. N0 starting number could be anything, right? So what fraction of bacteria culture will be left at 9:30? So fraction, so we can say n of t over n0. So this is the fraction left after whatever time. The time here is from 5 to 9:30, that means 4.5 hours, right? So we are looking for a time t. So let's write. So this is what we are looking for. At time t, t is from 5 to 9:30, that means 4.5 hours, right? 4.5 hours, correct? And here, let me write hours here. Half-life period here is 30 minutes. 30 minutes means half an hour, right? Or I can write 0.5. Let's say half an hour. Correct? Now, if I plug in these values here, I get half to the power of t is 4.5 and h is half, which is 0.5, correct? Let me write 0.5. Okay. In general, actually it was better to use half as such. See, I can extend this formula, write it in a better way, which is initial population, half, and if I write h as 1 over 2, it becomes 2t here. You see that? This is much simpler formula to use. In any case, this is as good, right? So half-life, we can write half as 0.5 hours. I don't want to confuse h with h, and therefore I'm writing hours here, okay? Now we can use our calculator and calculate what is half to the power of 4.5 divided by 0.5. So we know 4.5 divided by 0.5 is actually 9, right? But half to the power of, so we'll do within brackets 0.5 exponent, let me write in bracket 4.5 divided by 0.5. It gives me 1 over 512. So let me write in fractions itself. It gives me 1 over 512, right? So actually it will be divided by almost 500 times, right? So this much only fraction will be left after 4.5 hours. Do you understand? So whatever was the initial amount, it will be divided by 512 times. So that is a fraction of the bacteria culture left. Now part B is, at what time will the bacteria culture contain 1 over 128 of the original population, right? So that means this ratio we want 1 over 128. So I can now replace in this formula 1 over 128 and figure out what this is, right? So I'll use here half to the power of 2t, correct? 2t, this formula I'll use. Now 1 over 128, you know what is the power of 1 over 128? Let me again give you this. 2 to the power of 10 is 1024, correct? So if we divide by 2, we get 2 to the power of 9. So half of this is 512. correct? And if we further divide by 2, we get 2 to the power of 8, and this is 256. And if we further divide by 2, we get 2 to the power of 7, which is 128, right? Kind of, I want you to understand this, right? Kilobytes, 2 to the power of 10 is 1024. In many calculations, when we are doing doubling the time or half the time, we are always using 2 as the base. So now, 1 over 128 can be written as 1 over 2 to the power of 7. So this is equals to half to the power of 2t. So from here, we can write 7 is 2t, or 2t equals to 7, and so time is 7 divided by 2, that means 3.5 hours. So in 3.5 hours, our population will get reduced to 1 over 128. It makes sense, right? In 4.5 hours, it was almost 500 times, and this is 1 over 128 times, correct? So that's our solution. So the time, at what time will the bacteria culture contain this much? So the time will be 3.5 hours after 5 a.m. So the time will be 5 plus 3.5. So it will be 8:30 a.m. So 3.5 hours after 5 a.m., right? So the net time will be 8:30 a.m. I hope you can see it properly now. Okay? Do you understand the concept? So we got here that it will be 1 over 128th after 3.5 hours. So we started at 5 a.m., right? So 3.5 hours, 5 plus 3 is 8.5. So at 8:30 a.m., the bacteria culture population will be 1 over 128th of its original population. Okay? I hope you understand this application problem. It is very interesting and useful. Thank you.